Hello and welcome to this learning video. In this learning video, we are going to take one more problem on the Legendre's linear differential equation. So we have already taken example on this topic. So let us start with. So we have the problem solve x minus 1 whole cube d3y by dx cube plus 2 into x minus 1 whole square d2y by dx square minus 4 into x minus 1 dy by dx plus 4y equal to 4 into log of x minus 1. So this is the problem we have. Now as you can see, it is like x minus 1 dy by dx, x minus 1 whole square dx square, x minus 1 cube dx cube. Okay, so this is the problem of Legendre. So you can start with like given this and say this is to be my equation number 1. Okay, and what is this? If you are smart enough to write, you can write this is the Legendre's linear differential equation with variable coefficients. Okay, and what is our objective? Our objective is to convert this problem of variable coefficient into a differential equation with constant coefficient. So for that we have to make substitution. So put, what is that? Put x minus 1 is equal to e power z. This implies z is equal to log of x minus 1, and from this we can find out the value of x, and x is equal to e to the power z plus 1. Okay, now as you can see here in this problem we have up to 3 derivatives, so we have to convert this dy by dx into dy by dz. Then x minus 1 dy by dx can be written as d1, coefficient of x is 1, so 1 into d1 of y. Don't forget to specify that my d1 is derivative with respect to z. Okay, now the next thing is x minus 1 whole square into d2y by dx square is nothing but 1 square is 1, d1 into d1 minus 1 into y. Just to get the filling of Legendre's, I am writing is 1 into 1 square into, and likewise the last one, and x minus 1 cube into d3y by dx cube can be written as 1 cube d1 into d1 minus 1 into d1 minus 2 into y. Okay, now when you substitute all these values in here in this equation 1, then equation 1 imply, and why we are doing it? Because we want to convert this Legendre differential equation with variable coefficient into a constant coefficient. Okay, so what is x minus 1 cube? This is d1 into d1 minus 1 into d1 minus 2. I am taking y common throughout, plus 2 into, what is this, d1 into d1 minus 1 minus 4 into d1y plus 4 y common is equal to 4. What is log of x minus 1? Log of x minus 1 is z. So this is 4z. Okay, 4z. So this is, now multiply this. So this would be d1 square into d, so this is d1 cube, minus 2d1 minus d1 is minus 3d1 into d1, minus 3d1 square, minus minus plus 2 into d1, okay, plus 2d1 square minus 2d1 minus 4d1 plus 4 operating on y is equal to 4z. Simple. Now collect the like terms. So this is like d1 cube minus, this is one term, 3d1 plus 2d1 is minus of d1 square, then here it is plus 2d1 minus 2d1 get cancelled with that, and this is 4d1 plus 4 operating on y is equal to 4z. Simple. Now as you can see, we have converted the given equation, given differential equation with variable coefficient into a differential equation with constant coefficient. Okay, so now I am going to find out the complementary function, particular integral, okay, and followed by the general solution after finding out this. d1 cube minus d1 square minus 4d1 plus 4. Okay, so next I have to write down its auxiliary equation. Therefore, its auxiliary equation is, what is its auxiliary equation? You just have to substitute d1 as m. So this is m cube minus m square minus 4m plus 4 is equal to 0. And when you write this equation, then you know how to get the roots of cubic equation. You can make use of the calculator to get the values, or you can find it manually. So the values of this is 1 minus 1 minus 4 plus 4. So 1 and then cube 8 minus 4 4 minus 8, this get cancelled, minus 4 plus 4, then plus minus 2. So I am getting the roots as 1 and plus minus 2. Whatever method you have, you can find out, you will be getting this only. So I am having my roots like this. Therefore, write down CF. All roots are distinct. So just try to write down CF as C1 e to the power 1z plus C2 e to the power 2z plus C3 e to the power minus 2z. Okay, these are the roots. Now, after finding out the complementary function, let us find out particular integral. Now pi is equal to, what is my pi? Pi is 1 upon d1 cube minus d1 square minus 4d1 plus 4 into 4 e to the power, what is that? 4z, sorry, not e to the power z, 4z. Okay, now as you can see, this problem is of rule number or case number 3, because we have a polynomial in z. Okay, so what you can do is you can write 4 outside, taking d1 cube common. So the moment I take d1 cube common, so, or you can take 4 common, that would be easy. So if I take 4 common from here, that will get cancelled with this 4. So I remain with 1 minus 4d1, okay, 4 common, so 1 plus this d1 cube minus d1 square minus 4d1 by 4 into z. Okay, now you just take this to the numerator. One remark I would like to make: if you are not able to recollect what is case number 3, so you can just see the link. This link of this case number 3 is provided in the description of this video, so you can click on it, learn from there, and then you can solve this problem if you are not getting it. Okay, because we are applying rule number 3, and we have already learned this rule number 3 in the very beginning of this topic of higher order linear differential equations, okay, with constant coefficient. So this 4 get cancelled with this 4, and we got it to be 1 plus d1 cube minus d1 square minus 4d1 upon 4 power minus 1 into z. Now you have to expand this. Do you remember the expansion for binomial expansion for 1 plus u to the power minus 1? So if not, then I am writing here using what? Using 1 plus u power minus 1 is equal to, consider this bracketed quantity to be u. Okay, so this is 1 minus u plus u square minus u cube plus u to the power 4 minus u to the power 5 and so on. Okay, so applying this, we'll be getting pi is equal to, what is it? 1 minus d1 cube minus d1 square minus 4d1 by 4 plus d1 cube minus d1 square minus 4d1 by 2 whole square minus and so on into z. Okay, now let me tell you one thing: don't write more terms of the expansion. Why? Because we have to operate these expansion on the z, and here we have z power 1. So only out of these all these quantities, which one will contribute? Only one derivative will contribute. Because why this is so? Because I have z. If I take one time derivative, d1 is ddz of, okay, yes. So what is this? This stands for ddz of z. So what is its derivative? 1. What would be d1 square of z? d1 square of z would be d1 of z. What is d1 of z? Just we have seen d1 of z is 1. And what is d1 of 1? 0. What is this d1? d1 denotes derivative, and derivative of constant is 0. Okay, elementary things. Now operate this. So this is 1 minus, I am taking this 1 by 4 outside. Now 3 times derivative of z with respect to z, 2 times is 0, so 3 times must also be 0. Okay, minus 2 times derivative of this, it is again 0, minus 4, 1 time derivative of z with respect to z, 1, and these are square, this is square, so there are more powers of this d1, so this contribute to 0. Okay, this contribute to 0. Now what we remain with? We remain with 1 into z, sorry, 1 into z is z, sorry. Okay, so this comes out to be z minus 1 by 4, and this minus 4, so this become plus, so this is z plus 1. Simple. Okay, so yeah, so we have the CF and we have the PI. So we have the CF, we have this PI, then what you are waiting for? Just write down the complete solution. So let me remove this now. Therefore the complete solution is, therefore the complete solution, sometimes you call it as general, sometimes complete, is y is equal to CF plus PI. So what is it? Y is equal to CF plus pi, pi is z plus 1. Okay, so I am getting an advantage of writing on the board. So this is my solution, and as I gave a remark in the working rule that don't forget to resubstitute. Okay, so that is okay, but x minus 1 is equal to e to the power z. This implies x minus 1 whole square is e to the power z ka square, that is e to the power 2z, likewise minus 2z. Okay, so substitute, and what is z? and z is equal to log of x minus 1. Okay, so what is it? Therefore y is equal to c1. What is e to the power z? 1z is x minus 1 plus c2. What is e to the power 2z? X minus 1 whole square plus c3. What is e to the power minus 2z? X minus 1 power minus 2 plus what is z? Z is log of x minus 1 and this plus 1 as it is. Okay, so this is nothing but my required general solution for the given problem, and don't forget to write where. Being a good mathematics student, you should write where C1, C2 and C3 are arbitrary constants. Okay, so I hope this is clear to you, and you can take more problem on this topic for practice, so that this topic is should be prepared from your side. Okay, so thank you for watching and enjoy learning mathematics. Thank you.